Hello everyone, I am going to present our FCS activity on the topic state space to transfer function conversion for multi-input multi-output systems. This activity is guided by Dr. Vijay Kumar sir, and now I am talking on the introduction of our topic. In control system there are two common ways to represent a system. First is state space and another is transfer function. In state space this is used for the equation to show how the system changes over time, and another transfer function which shows the relation between the input and output of the frequency domain. And in this, changing from state space to transfer function helps us understand to multi-input and multi-output systems very better, and it is useful for the checking system stability, designing controllers, and analyzing system performance. And now talking on the MATLAB code. In MATLAB, we can easily change a state space model to a transfer function model. We use a function called SS2TF, and first we define for a matrix A, B, C, D, and because our system has two inputs, we find transfer function separately for each input by setting 1, and then IU is equal to 2 for second. This gives us all the transfer functions showing how each input affect each output. And now talking on the output, after running the MATLAB code, we get the numerator and denominator for each transfer function. There are polynomials in S, and instead of SS2TF, we can also directly use TF to get the transfer function form. This makes the system analysis even easier.
SYS is equals to RSS in bracket 2 comma 2 comma 2 percent to generate the random 2 into 2 system. ABCD matrix SS data in bracket SYS to provide a ABCD matrix for this system. Once we have a ABCD matrix, we can use a SS to TF transfer function to get the transfer functions. Because there are two inputs and two outputs, the transfer function matrix will be have four matrix functions: TF1 input 1 to output 1, TF2 input 1 to output 2, TF3 input 2 to output 1, TF4 input 2 to output 2. TF is equals to TF1, TF2, TF3 and TF4. Syntax for a SS2F TF is num in bracket num den. Here we can correspond to the input we are considering a. For example, we have a two input. First we will consider a IU is equals to 1 first input, that is the first input. This way we will get the transfer function from the input 1 output 1 and input 1 to output 2. Then we will take a IU2 is equals to 2. This will give a transfer function from the input 2 to output 1 and input 2 to output 2. Hence IU will go from 1 to 2. This is the matrix we are define here. So the transfer function will be given by num1 divided by den1 and num2 divided by den2. Here the num and denominator are polynomials and decreasing power of s, that is a s raised to 2 plus 0.5 s plus 2. Transfer function is the same result we can obtain using the transfer functions.
So this is the overall output of the simulation of state space transfer function for multiple input multiple output. This num1 and den1 are the numerator and denominator for the input number 1, where there are two numerators given, one for output number 1 and second for numerator of output number 2, and there is a common denominator for both the outputs. And similarly for num2 and den2 are the output of input number 2. Numerator 2 gives the numerator 2 gives the output.
Talking about advantages and disadvantages. Simplify system analysis in classical control. Enable frequency domain representation for controller design. helps in stability and performance analysis, used for MIMO system to analyze input-output relationship, support control techniques like root locus and board plots. At disadvantages, lose internal state information compared to state space models, complex for high order system with multiple inputs and outputs, less effective for nonlinear system requiring state space representation. And moving toward the conclusion, state space to transfer conversion simplifies system analysis, enables stability, assessment, and control design, while it loses internal state dynamics. It remains essential for understanding MIMO system. Using both representation together ensure a comprehensive system analysis. Thank you.